Welcome back to another M&S tutoring video, and in this video we're going to be learning how to solve linear quadratic systems. Well, what are linear quadratic systems? Linear quadratic systems are graphically any two systems that involve one parabola and one straight line. And the solution to a quadrilinear system has points for x and y that satisfy both equations, both the line equation and the parabola equation as well. So as you can see on my in my drawing right here is that all these blue points are solutions to both the parabola and the two lines below. The line passing through the parabola, which intersects it at two different points, is called a secant line, and a line that intersects with the parabola only at one point is called a tangent. As you can see, the points of intersection for the curve and the line are the solutions to it. To solve it graphically, all you have to do is you have to find the x and y coordinates of the points below. So if you want to graphically solve it, you just have to find the x and y coordinate for this point over here, and you have to find the x and y coordinates for this point over here. Now, without actually graphically solving it, how would you solve it using algebra? Well, algebra you could use to isolate for the variable, and then you can sub it back into the other equation. So say for example, the parabola that you're looking at has an equation of y is equal to x squared plus 2, and the line you're looking at has an equation of y is equal to x plus 4, let's say, right? And you want to try and find the solution. You want to try and find where this line intersects the parabola at. What point does it, or what multiple points does it intersect the parabola at? Well, to do this, we know that y is equal to x squared plus 2, and we also know that y is equal to x plus 4. Since we know that, we can sub in y for one other equation and make it so that it's x squared plus 2 is equal to x plus 4. Now that we have that, we can begin to bring all of our variables and all of our constants to one side of the equation and hopefully solve it using either factoring, completing the square, or the quadratic formula. So when I do that, I'm going to bring x plus 4 to the left side, and I can write x squared minus x plus 2 minus 4 is equal to 0. Right? Oh, sorry, that looks like a 6, doesn't it? Is equal to 0, right? So now I'm going to simplify the left side even further and write x squared minus x plus 2 minus 4, of course, is minus 2, is equal to 0. Now that I have a general quadratic equation, I'm going to go ahead and solve for the x value so I can find both the x coordinates at where the line intersects it at. So I'm going to solve it by factoring. And right off the bat, I can easily tell that this can be factored into actually x minus 2 and x plus 1, right? And it can be factored like that. But before we actually find out how many solutions after factoring, you can find out how many solutions if you don't want to factor and then find the amount of solutions, you can use the discriminant. The discriminant is basically b squared minus 4ac, and depending on whether your answer is positive, negative, or 0, it tells you how many solutions it has. So b in this case is -1, so -1 squared is 1, and then minus 4, a is also 1, and c is, in this case, is 2, right, -2. So it's 1 plus 8, and this makes 9 the discriminant, and since 9 is positive, we know that there is two different solutions because the square root of 9 gives you two different answers. Again, if the discriminant is 0, then there's only one intercept. The line is tangent to the parabola, as the square root of 0 only has one answer, 0. And if it's negative, it has 0 intercepts because there is no square root of a negative number, and it does not exist. So moving on, let's actually solve for the x intercepts for the parabola and the line. So we can isolate for the first bracket here, x minus 2 is equal to 0, and we can isolate for the second one, x plus 1 is equal to 0, and we can solve for the two different x values. So x can be 2 and x can also be -1. Right? Now that we have both the values for x, we can sub it into either one of the equation. We can sub in both the x values. Let's say we want to sub it into the bottom equation because it's a lot more easier. Doesn't involve the square. So I can sub in x for 2 and get y is equal to 2 plus 4 and get y is equal to 6, meaning one of the points is 2 and 6. And now I can sub in x for -1 and get y is equal to -1 plus 4 and get y is equal to -3. Sorry, no, +3, +3. And I know that the other point of intersection is -1 and 3. And just like that, I have both points of intersection for both the parabola and the line that's intersecting it. And now that I have both the intersections, I know the line is secant because it intersects the parabola 2 times. Now, what if I had a question that stated, determine the y-intercept of a line with a slope of 4 that is tangent to y is equal to 1 over 2x squared plus 2x minus 8. So what this question is asking is, what if you had the slope of the parabola? Let's say the slope of the parabola was y is equal to 1 over 2x squared plus 2x minus 8. What if you had the equation of this parabola over here, but you also only knew the slope of the linear equation of the line? You only knew that it was y is equal to 4x, and you didn't know the y-intercept, and you wanted to figure this out. How would you actually do that? Well, let's go into this equation and learn how we can solve for this equation, knowing that it is tangent to the parabola. So first of all, we're going to do the same thing that we did up above. We're going to isolate both of them for y, as they already are, and we're going to equate both of these equations. And we're going to write 4x plus b is equal to 1 over 2x squared plus 2x minus 8, right? Now let's go on and simplify this and move everything to one side of the equation. And after we do that, I'm not going to show you all the steps. I'm just going to go straight to it. You get x squared plus, sorry, you get x squared minus, not x squared plus, you get x squared minus 4x. You get x squared minus 4x minus 16 minus 2b is equal to 0. Remember how I mentioned the discriminant up above? And I told you that if the answer is positive, then there's 2 intersections and the line is secant. And if it's 0, the line is tangent because there's only 1 intersection. Well, we're actually going to use the discriminant in this case to find out the y-intercept, the actual b value in this case. So what we're going to do right now is we're going to use the discriminant, but instead of having a c as the actual constant, we're going to use this whole little equation over here as c. And we're going to use again -4 as b, and we're going to use 1 over here as a, right? So the discriminant, of course, is b squared, so -4 squared minus 4 times a times c, but in this case c is -16 minus 2b, right? And now that we have that, we're gonna write we're gonna go ahead and solve this, because we know this whole discriminant equals to 0 because we know that the 2 lines are tangent. So we're gonna go ahead, we're gonna expand the left side of the equation, and we're gonna solve for b to get the y-intercept. So -4 squared is 16 minus 4 times 1, which is 4, of course, and then we have to expand this entire bracket over here is equal to 0. Now, when we go on to expand the bracket, one thing you have to remember is that since we know the line is tangent, that's the only reason we can use this to solve for the y-intercept. If we knew this line was a secant line, we couldn't really solve for it because the answer could be any positive number. It did not have to be necessarily 0. So that's just a quick reminder for you guys. if you wanted to solve this and the line was secant, you really couldn't, because there would be an infinite amount of answers. So let's go on and continue to solve this equation. And to solve this, it would be -4 times -16, which was 64. So 16 plus 64 plus 8b is equal to 0. 16 plus 64 is 80. So 80 plus 8b is equal to 0. And scroll down a bit lower, we get 8b is equal to -80. And finally, b is equal to -80 over 8, or b is equal to -10. Right? It's really that simple. And now that we know the y-intercept of the line, we can write this equation, moreover, rather, as y is equal to 4x minus 10. So that's all for the video, guys. I hope you learned something new. If you have any comments, concerns, please feel free to leave it down in the comment section below. Other than that, thanks for watching, guys.